Second part to solving systems of linear equations. So in the first video, we solved by substitution and elimination. Okay, so here we're going to solve by graphing. Okay, so as we learned with graphing, this is our y-coordinate of the first one. So we cross the y-axis at 4, and our slope is 5, 7, meaning we go up 5, 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7. Okay, now I'm going to do my absolute best, but this probably be off a little bit because it's really hard to draw a straight line here. Okay, so this would be y equals 5/7 x plus 4. Okay, now if I do the same thing with this, well, here I cross the y-axis at -2, and here I go down 1 and right 7. So down 1, 1, 2, 3, 4, 5, 6, 7. Okay, so there, oops, down 1, right, 1, 2, 3, 4, 5, 6, 7. Or I could have went up 1 and left 1, 2, 3, 4, 5, 6, 7. And that's just because, think of 1/7, -1/7. That could be -1 over +7 or 1 over -7. It doesn't really matter. Okay, so if I connect these dots, ooh, something like that. Hopefully your lines are better than mine, guys. They better be. Okay, now the solution is going to be where they cross each other. So luckily for us, that's actually a point that we know is on the graph. So -7, -1 is where they intersect. So that's actually going to be my solution to this. Show you what a no solution problem can look like. Okay. And we can use this for substitution or elimination. But to make lives easy, I'm going to use elimination here and multiply this by 3. Because if I multiply this by 3, this will be a -3x, and when we add it to the 3x, the x's will cancel. Okay, so when I multiply this by 3, I get -3x plus 6y equals 18. Okay, so I just multiplied everything here by 6, and I'm just going to write this below it, just because it's easier to work with ones on top of the other. Equals -9. Okay, now if I add these, okay, -3x and 3x goes away. They eliminate each other, which is what we wanted. But notice here too, 6y minus 6y also eliminates. So what we get on the left side is nothing. 0 equals, but 18 plus a -9 is just a 9. Okay, and sometimes you get no solution and infinitely many solutions confused, but think about it this way. There is no value of x and y that we can plug in that will ever make 0 equal to 9. Okay, so because 0 will never be equal to 9, we would say this has no solutions. Okay, now let's look at infinitely many solutions. Okay, what does that look like? Well, this works out nice for substitution because we already have y by itself. So if I know y is equal to 3x minus 1, I can substitute 3x minus 1 in for y in the other equation. Okay, so I'm left with -6x plus 2, my y is 3x minus 1, equals -2. Okay, and this looks longer, but notice we only have one variable, so -6x plus 6x minus 2 equals -2. Okay. -6x plus 6x, these cancel each other out, so I'm left with -2 equals -2. Okay, now it doesn't matter what we plug in for x, doesn't matter what we plug in for y, -2 will always be equal to -2, so that's when we say this has infinite solutions. Okay, any x and any y will yield -2 equals -2, or 5 equals 5, or 0 equals 0. All right, now let's look at these graphically. Now remember, our solution is where they intersected. Okay, so think of it this way. Let me just draw an axis for all 3 of these. So here's an axis for this one, Here's an axis for this one, and here's an axis for the last one. Okay. So what would the graph of the system equations look like with one solution? Well, that just means they intersect at one point. So maybe we have a line here, and then maybe we have a line here. Okay, and notice they intersect at this point, and this would be our solution right there. That point right there would be one. They intersect twice, which lines will never intersect twice. Then it would have two solutions, okay? If it intersects 8 times, then it has 8 solutions. But when we're talking about 2 lines, they can only intersect at one point, okay? So no solutions. That means that 2 lines would never intersect. Okay, so say we have a line that looks like this. Okay, a line that will never intersect this would have to be a line that is parallel to it. Okay, so parallel lines intersect. Okay, and so that would be when we'd have no solutions, when we have 2 parallel lines. Okay, now infinitely many solutions, maybe we have a line that looks like this. Okay, and if it has infinitely many solutions, that means they're always equal to each other. So maybe the other line is right on top of it. We'll pretend that that's right on top of it. And it would look just like that. Well, one line is directly on top of the other. That would be infinitely many solutions.